Okay. Wait a minute. No, don't do that. Okay. Okay. I'm going to go through number 1 here. Then I'll chill. I'm hoping at this point, okay, we can separate related rates from optimization, right? 2 different kinds of questions. This is a related rates question. And they're telling you, or I'm telling you, that the rate of change of area is positive 4 square inches per second. Cool. And I want to know how fast the radius is changing. So like all related rates questions, we need a formula that links area to radius, because those are the rates we're playing with. You just derive that thing with respect to time. So we are going to get, this is pretty straightforward, dA dt is 2 pi r dr dt. Okay, and that's how we're going to find our answer. We want dr dt is right there, we just got to plug in. So dA dt is 4, I'm going to do this right up here. Boom. We have 2 pi r, I don't know r, and we need to know that, because what I'm looking for is dr dt, right? This is what I'm missing. So we're not supposed to know dr dt, which means we've got to find r. So somewhere in this question, the book, the test, whatever teacher you have in the future, has to tell you something about something. And they tell you that the area of the circle is 36 pi square inches. And all that allows us to do is find the radius right here. Because if the area is pi r squared, and maybe you all know that it's just 6, right? You can see that it's going to be 6. And I find it's easy when like the numbers are easier. When you have volume or area or something like that and like weird numbers, sometimes it's less intuitive to see that. But if the area is 36 pi, that means that r had better be 6. Okay? And that just allows us to take that and drop it right in there. So we get that 4 is 12 pi dr dt, right? That's what that simplifies to on the right-hand side. And then if we come over to here, all we're going to do is divide by that 12 pi, okay? So dr dt is 4 over 12 pi, which happens to be 1 over 3 pi. And the units on the radius are inches, and because it's a rate of change, that's per second. Okay? Pretty straightforward. Hoping tomorrow, again, little quiz, very similar. It could be volume, sphere, or something, but same idea. All right, so make sure you know those formulas of area, circumference, volume of a sphere, surface area of a sphere, right? We've had those a bunch. B says, how fast is the circumference changing? Well, the circumference formula for a circle is just 2 pi r. And if I asked this question first, this would be a problem because we didn't know what dr dt was. But now we do know what dr dt is. Right? It's right there. We already found it because it says at the same exact moment when the area is 36 pi inches squared. Okay? Good morning. So dc dt is just 2 pi dr dt. Super sweet. Thank you. And since we want dc dt, I need to find dr dt, which we already found. If we hadn't found that, we'd have to go back and find it somehow. Okay? But dr dt was just 1 over 3 pi. And the pi's cancel there, and we're left with one of our favorite numbers, 2/3. And because it's circumference is a length, gang, so that's measured in inches per second, because it's the rate of change. Oh. Good? Yeah, you got that. Hell yeah. That's no problem. All right. So here we go with number 2. You guys feel? How are we feeling? Thumbs up, thumbs down, middle finger. This is an easy question. That was a joke. Cut it out, Karen. It's in the video now. People think you gave me the see. Oh, it's so quiet in here. But now I said your name on the video. You're doomed for doomed. You're ready for stardom was what's going to happen. Okay, I taught Tom Holland a couple years ago. See what happened? I'm just kidding. He's from England, I think. It's good. Oh my God. All right. We have a tank. Here's our tank. Yay. You don't have to draw a 3D. But the radius is 5. And the height is 10. And it's being filled with some stuff. Water, it looks like. Great. Yeah. And the screen is frozen. Thank you. Yeah, there we go. That's what that looks like. And the water in the tank has a radius and a height itself. And before we even do anything else, just we saw these tank questions. That lets us know that 5 over 10 has to be R over H, right? That's pretty simple. All right, but then we're going to read and see what they're telling us. They're telling me it's being filled at this rate. That's dV dt. Boom. We want to know how fast the depth is changing. That's dr dt. Okay, so I'm asking for what is dr dt. And since I know dV dt, we're going to set up a volume equation. No, that's height. Guys, help me out here. We want dH dt. There we go. Right? So I need a volume equation with height, and we know the volume of a cone, because it comes to a point, is a third the area of the cylinder, right? But we're not going to work with that because we don't care about the radius at this point. We don't care about dr dt. We want to get rid of r. So we're going to use this equation right here. I hope this makes sense. You're going to see that r is equal to a half h. And we're going to drop that right in here. And when you do that, you're going to get, I'm going to put the pi over the 3 there. Okay, pi over 3. You're going to square r. It's r squared, right? So you could write it like this. Like you could write 1/2 h squared h. Okay? But we all know that a half h squared like that. So just because sometimes you mess up parentheses, that's going to be a 4th h squared times h. Okay? Just square it as you write it in there. You don't need to write it in parentheses. Just square it out. It's going to be pretty simple. Just becomes that. So this whole volume equation is really pi over 12 h cubed, which is super nice. That's a very, very simple equation. Okay? That's what volume is. So let's write that over here and do all this work. The volume, if you need me to go back, let me know. But we get here, which means dV dt, which we know, is pi over 4. That's me canceling that 3. Like the 3 comes down, right? And 3 and 12 cancel. You can do that in this step. You can write 3 pi over 12 if you want. You can write pi over 12 times 3. It doesn't really matter. But it's going to be pi over 4 h squared dH dt. And this is what we're looking for right here, which means I need to know all the other junk. So, dV dt, I told you was something ridiculous, 8 pi. There we go. So this is 8 pi. This is pi over 4 h squared. Do I tell you h? What's happening in this question? Nope, I'm telling you the volume. So we don't know the height, but we do know the volume. And because we know the volume, we can find the height with this equation right here. Okay, the volume was, I forget already, 9 pi over 4. So all I'm going to do here, remember, if you know one value, you can find the other if it's an equation linking them. So we get this. And if I did this correctly last night when I made this, this number is going to work out relatively nicely. Okay? So can we solve that for, do you guys see this? We're going to multiply by 12 and divide by pi to get h cubed. So h cubed is going to be equal to, I'm not going to do 12 times 9 because this is going to simplify down, okay? And the pi's just cancel. That's what h cubed is. Okay? So 4 and 12 cancel out to a 3, right? That's a 3 there. So h cubed is really just 27. And that's super sweet because then h is just 3 at this moment in time. Again, if I was nicer, I would have just told you in the problem h was 3, but I'm such a tough teacher, I told you what the volume was and you had to find the height. But now we know the height, that just gets plugged in. Remember what we're doing down here, dV dt. We just did all that work up here, right here to find h, right? That's what that was. That was finding h. h is 3. We're going to plug that into there. So h is 3, so this is a 9 dh dt. And then we're going to solve that for dh dt. And we're just cross multiplying here essentially, gang. We're going to multiply by 4, divide by pi, and divide by 9. That looks like this. 32 over 9. And if you got there while you were working in class, good for you. And if you didn't and you have any questions, you can let me know. It is my job to help you. And the units on that are, so it's a height, so it's feet, and it's a rate of change, so it's per a time, and I used minutes in this problem, so feet per minute. All right. Here we go. Woo! If you drew a picture, what did Kara say?
Nothing.
I want to know.
No, you don't.
Oh, we don't. Yeah, there we go. Have you guys seen the Spider-Man? Have you guys seen the new Spider-Man? Some of us have. Did you know who all the other characters were from the old movies from when I was a kid? Good. Bridging the generations. Anyway, this should be your setup, I hope. Okay? There's a lamp. Remember, the other version of this, when the lamp is on the ground, the shadow's on the wall. It's a vertical shadow, okay? But we're going to say that h over 5 is equal to x plus h over 30. And I told you, specific to these kinds of questions, you should cross multiply and simplify this out. Okay, before we start deriving it. But we do know that dx dt is 3 feet per second, right? That's what dx dt is. Positive 3, because we're moving away from the lamppost, and we want to know how fast the shadow is changing. So the question is, hey, what's dh dt? All right, so we're going to use this equation here. We're going to cross multiply. That's going to tell me that 30h is 5x. That's not an s, that's a 5. Plus 5h, right? And then we're going to simplify a little more and find out that 25h is 5x. Cool. I mean, you drive it right there. That's super easy. You find that 25 dh dt, 25 in there, right? 25 dh dt is 5 dx dt. Okay? How are we doing so far? You get here? We're good? And we know dx dt is 3. So 25 dh dt is 5 times 3. And look, if I mess up, gang, you gotta let me know here. I'm recording this for, future generations. Okay, everybody good? This makes sense? We agree with these numbers? So then dh dt, when you divide by that 25, a 5 cancels, is just 3/5. And what's that in feet? Feet per second. So that shadow is getting longer as they walk away from the lamppost at 3/5 feet per second. At that moment in time, but really the whole time for these kinds of questions. Good? Yes, ma'am. Sometimes they provide a picture. I did not in this particular case. Let me get a little bigger pen here. Okay. So here, 3, 4, 5. Those are all the same. Okay, 5 pens. And this dimension is W, I'll call that. So those are all W's in there. And you can call it, again, one big L if you like, or call them all little L's. Okay? That's what we're working with. Let me shrink this down some. All right, so the area of each one is 25. That's fixed. And again, we know this is an optimization question, right? Not a related rates question. We're asking about what's the least amount of something. So the area, which is length, width, that's a W, has to be 25. And all that's going to allow us to do is sub out one of our variables from our optimization equation. And the amount of fence we need, since we're trying to find the dimensions that require the least amount of fence, I want to minimize the amount of fence, we need an equation for the fence, and that's 10 L's and 6 W's. Everybody okay with that? We can get here. Okay? We want the minimum, we want to minimize this. And the way we find the minimum ever, doesn't matter how, like, the situation, if it's confusing, whatever, they actually find the minimum, you're going to find the derivative, find out where it's 0, okay, or undefined, and see where that changes from negative to positive, all right? But in these kinds of questions, there's only going to be one answer. All right, most of the time, that's not true. If you took, like, we had some harder questions, there could be some weird stuff happening, but I'm telling you, for us, it's going to be like one answer. This is what's going to happen, okay? So, we're going to derive that, but we got too many variables, so that's where the area comes in. It doesn't matter which one you solve for. I'm going to solve for W. W is 25 over L, which means my fence equation is exactly the same as 10L, plus if you plug this in for this W here, we're going to get 150 over L. Are we okay with that? That's our step we need to get down to one variable. And then, because we want to know where that has a minimum, again, the graph of that equation, F versus L, looks like this. Cool? There's a minimum point somewhere. I want to know what is the value where that happens. Well, the slope is going to be 0 there. You can see it. So we find where the slope is 0. So the slope is df over dl. We're not deriving with respect to time. That's 10 minus 150 over L squared. And I just want to know where is that 0. Okay? Oh man, Ben, you had 125, right? Because did you have 5W? You had a 125 in your answer. Did I mess up?
Yeah.
What did I mess up? Why don't you tell me this? 1, 2, 3, 4, 5, 6. What's up? Did I not mess up? We're good. Okay, there's 6W. Okay. Because even if you did, if you're doing this, you're like, oh crap. That's a small thing. I mean, obviously you don't want to make like little mistakes like that, but that's a small thing. If you get the overall picture of what's happening, that's good. Okay? But if you messed up one small thing, you know, again, just take note of it. I do it all the time. You see me daily. So if we want to find where this is 0, we're going to get a common denominator, and that's going to be L squared. Okay, so I'm multiplying this 10 by L squared over L squared, right? That's 10 over 1. Okay? And you don't really have to do that. You can solve that however you like. I think it's easiest to get it as one big fraction, which is what we have. And that's going to be 0. The denominator is it's undefined when L equals 0, but that doesn't matter for us. Okay? The numerator will be 0 when L squared is 150 over 10, which is 15. Okay? So L is really plus or minus root 15, but because it's a length, it's just 15. And if we made a number line for that, you're going to find out the derivative is negative and then positive. Okay? That's a no. And then we want to find the width, so let's finish that up here. Remember the width was what, 25 over L? So the width is just 25 over what L is. And if you do rationalize that, you get 25 root 15. You don't have to. This is a totally fine answer. I'm just saying if you did rationalize it, you would get that. And that does simplify slightly. That's 5 root 15 over 3. Okay, so you can write W like that too. Everybody good? Excellent. So, having a graph of this makes it a little bit sweeter. So, that's what this graph looks like, right? It should be, I can do better than that. Okay, so there's that. The 0.40 is up here somewhere. I mean 0.4. And we're saying, again, there's a point on that graph that is closest to that point. All right? You can picture it's like somewhere like right here, perhaps. Is that okay? And there's also another one on this side, so we're going to get 2 answers here. About okay? And let's just to highlight, you don't need to do this for this question, but just to make sure this is making sense, what we're doing, not just memorizing these steps. Okay? If I were to have a point on this curve, let's say it was up here to here to here, what's the distance between this point and this point doing as I move the point closer? Is it getting bigger or smaller? he's getting smaller. The distance is getting smaller, right? It's getting closer. Until I get somewhere around here, and then it starts to get longer again. You see that? Until I get to 0. Do you guys see that 0 is going to be like the furthest distance away? There. And then as I move it around this way again, it starts to get smaller again. You can see it happening. Like the distance is getting smaller. Go until I get to here. And then it starts to get bigger again. That's what's happening. Okay? But either way, the distance between any point on this curve, which is x comma y, but y is distance between 0, 4 and that point from the distance formula is the square root of x minus 0 squared plus x squared minus 3 minus 4. And you can just make that x squared minus 7 right away if you know what you're doing. Everybody okay with that? So that's, to write it again, that's x squared plus x squared minus 7 squared. So that is, I told you to simplify the inside of this. To square that out, it's the first thing squared minus double them together. That's 7x squared doubled, that's 14x squared. Plus the last thing squared, that's 49. And finally, just in our simplification of this formula, we have x to the 4th minus 13x squared plus 49. And we said that represents the distance between any point on that graph and 0, 4, just based off its x value. Okay? Ready? It's stupid to just make sure we understand what this actually does, which again is not crazy important to get through this class, but just so we understand. What's the distance from this point here to this point here? How far is that distance? It's 7, yeah. It's 7, yeah. I like the enthusiasm. It's 7, right? What that means is, when the x value is 0, the distance should be 7. What do you get when you put 0 into there? Oh my goodness. You get root 49, which happens to be 7. It just works. That's what it does. Okay? We want to find where that's the smallest it can possibly be. So we derive it, and we find where the derivative is 0, because that's where minimums happen. The derivative of a square root is 1 over the square, or 2 times the square root of the same thing. That's a half to the negative a half. That's what that is. Times the derivative of the inside, which is 4x cubed minus 26x. Everybody good? That's our derivative. That tells us how the distance is changing as I move that point. I want to know when it stops changing. When is it 0? So we factor the top. That gives me 2x times 2x squared minus 13 over this whole mess. But really, we only care about the numerator because I want to know where this thing is 0 or undefined, and the denominator is never undefined. Okay? In this particular case. So you get either, everyone understand what we're doing here? 2x is 0. We need this to be 0, right? Either 2x is 0 or 2x squared minus 13 is 0. This yields x equals 0. And this over here yields, so you can factor this like a difference of 2 squares. It factors like this. That's like the conjugates, okay? That's how that factors. But you can also add 13, divide by 2, and take the square root. Either way, you're going to get plus or minus the square root of 13 halves. All right? Now we have 3 answers. They're not all answers, okay? We got to check. So in a question that we did on the last question, number 4, which you guys will see in a second, there's only one answer, and that's just it. Okay? You should make a number line and check, but if you only get one answer, I promise you that's it. Okay? But for a question like this, we're getting 3 answers, and that's because, let's draw a little derivative number line, dd over dx. There's negative square root 13 over 2, 0, and positive square root 13 over 2. If you think about what's going on, the answers have to be these 2 right here. All right? And that's because, again, if we go back up to this graph, remember we said there's 2 points that are closest? One's right here, and one's right here. There's a negative value and a positive value. That's going to be negative root 13 over 2 and positive root 13 over 2. The reason why 0 pops up is because that's going to be a maximum for the distance. Okay? So if you check these values in the derivative, boom, boom, boom. So if we look at that derivative up there and we plug in values, guys, I don't know what root 13 halves is. I know 13 halves is 6.5, so the square root of that has to be 2 something. All right? But anyway, you know a number down here is going to be like negative 10. So if you plug that into your derivative up there, you're going to find this is negative. And this is always going to happen for these kinds of questions. A number in this interval would be like negative 1. If you plug that in, you're going to find out the derivative is positive. Which again makes sense. Think about this. Here's our point. As I move here, the distance is getting smaller until I get right to here. Then the distance gets bigger until I get to here. That's what's going on. Then the distance gets smaller again until I get to here. And then it gets bigger again when I get past that point. That's what that number line tells us. I hope that makes sense. So, the x values are plus or minus root 13 halves. But I asked you for the points, and because it has to be on this function, the answer to this is plus minus, and you can write them separately. It's like positive root 13 halves, comma. If you plug root 13 halves into here, root 13 halves squared is 13 halves minus 3, which is 6 halves. So that's going to be 7 halves. Be careful, don't do like me. It's root the whole fraction. So these are the answers to that. Okay? What's up? What's it called? Optimization?